Hi, my geometry students. Today's video is a quick one, and if you notice, I'm actually at school right now. All right, all I wanted to talk to you guys about is that the review that we are going to be doing tomorrow in class, whether you're at home, all right, or whether you're in school, it starts on page 21 of the packet. All right, it got a little chopped off. It says quiz review up at the top here. There are 12 total proofs. Okay? And what I mentioned to class today is that you do not have to do all of them. What I'm going to suggest is that you do at least half of them. So that's some quick algebra right there. If there's 12 proofs, I want to see when you submit that you've done at least 6 of them. All right, so I'm going to say 6 plus is how many of these proofs you need to do. They don't have to necessarily be the first 6, all right, but you need to do at least 6. I'm going to post answers, all right, and what I'm going to want to see is when you submit it, I'm going to see how many that you did. So if you did the first 6, fine. You did the last 6. If you kind of hop around, or if you're like, I want to do more practice than that, I'm going to try all 12 of them, or I'm going to try 8 of them. So you can pick, but you need to complete at least half of the proofs that are in here. What my suggestion would be is that you look around and see, am I trying proofs that are maybe a little bit different? So when you look at the vocab terms. So like number 1, you've got a midpoint. 2 has parallel and a midpoint. So that one might be a little more involved, might be a good one to look at, right? When you hit the next page, we've got some median and altitude. Those are terms that we haven't seen in a little bit. Those might be worth looking at. The one that I wanted to talk about with you is actually on the next page. So on the next page, number 5, you've got a little parallel. And then the one towards the bottom, one of the givens you might not have seen before. This one that says segment GLFHS. All that is doing is just clarifying that that whole line is a segment. It's not broken or bent or anything. It's just one straight line segment. Same thing with segment DFM. It's just clarifying that that is one straight line segment there, right? So when you go to do this little proof here, right, you're going to set up, like you always would, your statements and your reasons. There should be enough room in your packet. If there's not for some reason, then of course, you can make a little adjustment, or you can use some separate paper, whatever works best for you, right? In the case of that first given, though, I'm not expecting you to say anything from it. You can just throw it in there, all right? So GLFHS and then segment DFM. So cool, we know that's a straight line segment. I would absolutely go right on to the next given. So because there's not a ton of space, I'm going to put it next to it, that GL is congruent to SH. And then in the diagram, I can mark that this segment is congruent to that one. The fact that I don't have any vocab terms to work with, though, means I'm going to keep going. So I'm going to put that F is the midpoint of segment LH in here. So this is the midpoint of that segment. At this point, I'm hoping that that purple sheet is getting pretty common. You're able to pull up a lot of those vocab terms right off the bat. Otherwise, that's what you need to study between now and the quiz. So midpoint implies 2 congruent segments. And so in the diagram, if L to H is my segment, then I should have this segment here, LF, congruent to FH. All right. Step 3. Well, where the heck are we going with this thing? Well, you are trying to prove that triangle GFM is congruent to triangle SFD, so the big triangles. So the fact that I have these little segments here and little segments here, that's not a side in the triangle unless I put it together. So if I want to put these 2 segments together and put those 2 segments together to create an entire side of the triangle, we need to use a little addition postulate. So I've got GL and SH here, LF and FH there. Think about the parts you need to add. GL and LF are going to give you that whole segment. So it's the first thing in each of my statements here. So GL plus LF is going to be congruent to, if I add these guys together, SH and then FH. And that is my addition postulate. I'm going to slide up just a little bit. Hopefully you can see everything okay. And then I'm going to rename it. This is now segment GF. That is now segment FS, or SF is fine too. And those are sides in the triangles I'm trying to prove. So I can say, now I've got a pair of sides. All right. We have one more given we haven't used yet. and that is angle G is congruent to angle S. So when you look in the picture, G congruent to S, that's a pair of angles in the triangle. Thank you very much. That's a given. All right, at this point, you've run out of all those givens. So you're looking for either reflexive or you're looking for vertical angles. So you look at the diagram. They don't share any sides this time, but we have those nice straight line segments, which now makes sense why that first given was there. So here, we've got vertical angles. And now I know you don't need a given for vertical angles, but it's just clarifying the diagram because this is a pretty busy diagram going on here. So to make life easy, I'm going to call that 1 and call that 2. I'm going to make step 5 that angle 1 is congruent to angle 2 because vertical angles implies that we have 2 congruent angles here. Please make sure you write the full step. Writing only half the step gets you only half the credit, okay? Please make sure to finish that thought. That is another pair of angles. So now in the picture, we always use either a hand or a Post-it or something and kind of cover up so you can see that we have one angle here. Here's one side. And then I probably should have made that a little double swipe there just to make it clear. Here's a second pair of angles. So if I connect the dots between the vertex of one angle and the vertex of the other, that is the side that we have. So that means that I would list the side physically in between those angles. So I can say triangle GFM is congruent to triangle SFD by angle side angle of one triangle congruent to angle side angle of the other triangle. All right, that is one proof down. You need to complete at least 5 more. All right. So you can check your answers. If you have ones that you want to request to go over in class, you can add that to the post video question. Thanks, guys. See you later.